Okay, 10.4 is using inscribed angles and polygons. Okay, so in 10.2 we talked about central angles. Now we're going to discuss inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain points of the circle. So it looks something like this.
Screen closer.
I'm drawing stuff just not working now. I handed it to you and you came up and got the 10.3. Okay, so inscribed angles, like this, we're going to label this A, B, C, and we'll have this as circle. So we'll say that angle ACB is inscribed in circle C. Okay, an intersected arc is the arc that lies in the interior of the inscribed angle and has endpoints on the angle. So this would be AB. Is the intercepted arc of angle A. You notice the arc AB will contain the last two letters of your angle. Arc AB is the intercepted arc of angle A. So the two endpoints of the angle by the arc is 4 minutes. The measure of the inscribed angle theorem, this is kind of an important one, so we're going to highlight it. The measure of an inscribed angle is 1/2 the measure of its intercepted arc. That means angle ADB is equal to 1/2 arc AB. Or you can say arc AB is equal to 2 times the measure of angle AB. So the angle is half the arc is twice as big as the angle. So in this next example, they say that angle ABC, so here's ABC, is 30 degrees. They want you to find arc AC. Okay, Jeremiah, what is the arc AC? What is the measure of arc AC? if the angle is 30 degrees, based on our two formulas that we just talked about, so the angle or the arc here is equal to 2 times the angle. So what would be the arc? Technology.
That's for sure.
So the arc equals 2 times 30, which is 60. Any questions over that? Okay, the next one then, we have our angle and our arc of 96. Okay, so the angle and the arc are related. They're not equal to each other, but we are going to set up an equation. We're going to say that 2x plus 1 equals 96. They're not equal, so how can I make them equal? I can't subtract yet. Yeah? Very good. The angle needs to be twice as big to get it to be the arc. So we can multiply this by 2. I could do it differently. Anyone have another idea? Yep. Very good. Or I could say that 2x plus 1 equals 96. And it's half of 96, so you divide it by 2. Either way, you can set this equation, it will work with the same answer. So we're going to solve this one. I'm going to just start this slide. We're going to do both of them. So 2x times 2 is 4x, plus 2 times 1 is 2. And we'll subtract that 2. Therefore, x equals 94. Divide by 4. Divide by 4. We get x equals 23.5. And that's all it asks us for with x, so we're done. Okay, now I'm going to solve the other one just to show that it also is congruent. Or sorry, it's equivalent to that same equation. So this is going to be 2x plus 1 equals half of 96 is 48. We're going to subtract 1. That'll give me 2x equals 47. Divide by 2. Divide by 2. And I get 23.5. So it doesn't matter which way you decide to write this equation, you'll still get the same answer. Any questions over that? Okay, the next theorem is if two inscribed angles of a circle intercept the same arc, then the angles are going to be congruent. So So in that first one, it says that angle ABC. So ABC, this angle right here is 45 degrees. They want to know what that intercepted arc is going to be. Jasmine, can you tell me what the intercepted arc would be? The angle 35. Okay, the intercepted arc doesn't equal the intercepted arc does not equal the same value as the inscribed angle as the essential angle. 70 is twice as big. So we have to do 2 times 35 would be 70. Then they want you to find ABD, so ADC, this angle right here. Remember, what's that angle going to be? Very good. You're going to take the 70 now and divide it by 2. Times by 1/2. Get 35. Since angle B and angle D intercept that same arc, we can now say that they're congruent. Is it less? We don't need to go through all that work, but we can if we don't remember that those 2 angles, because they have the same intercepted arc, will be congruent. Any questions? Okay, the next one. They gave you that AE, arc AE was 90 degrees. So we need to find the measured angle ABE. So this angle here, ABE. Brandon, what's that? How am I going to find the angle ABE? Very good. So 1/2 times 90 is going to be 45. Now ACE, so here's ACE. Alex, what's ACE going to be? The angle smaller than the arc, not bigger. So 45 again. It's going to be 1/2 of 90 again. Okay, so they intercepted that same arc. Now angle ADE, it too is going to intercept that same arc. So class, what should it measure? 45. Okay, so since all 3 of those angles have the same intercepted arc, all those angles are going to be congruent. Right. Okay, inside polygon. A polygon is inscribed in a circle if it has all of its vertices lie on a circle. So I say we're going to inscribe that square on that circle. We'll label this A, B, C, D. Let's go to circle P. And we would say that square A, B, C, D is inscribed in circle could also say then circumscribed circle is a circle that contains the vertices. So that's how you describe the circle. Okay, so we'd say that circle so then I wouldn't have recording. Okay, there we go. Circle P, circum, yeah, no, first, okay, there we go. Circumscribed. Oh,
What's wrong?
where A, B, C, D. Okay, if a triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. Okay, and the converse is also true. So okay, if the longest side of a triangle is the diameter of a circle, then it is a right triangle. If the longest side of a triangle is the diameter of a circle, then it is a right triangle. So that's how you're going to know if a triangle is inscribed in a circle or actually in a semicircle, then it's going to be a right triangle, always. Which makes sense because this whole arc would be 180 degrees. So this angle, so that's the inscribed arc, would be half of 180, which is 90. Next one. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So you need those opposite angles to be supplementary. So that would mean the measure of angle 1 plus the measure of angle 3 would have to equal 180. The opposite angles are going to be adding 180. And someone raise their hand and give me another angle. Okay, those are also opposite angles that are also equal 180. Any questions? So to find x and y, we need to write those equations. So 100 and x are opposite angles. So x plus 100 has to equal 180. So x would equal. Okay, Sydney, what's another equation I can find used to find y? So 95 plus y also will equal 180 because those opposite angles are also supplementary. So that means y would have to be 85. Any questions over that? Okay, I want you guys to do the next one on your own. Okay, we're back up here. So we should have I'm trying to get there. So this should be 3x minus 8 plus 5x plus 2 equals 180. You're going to combine your like terms and get 8x minus 6 equals 180. So I'll give you 8x equals 186. So x equals 23.25. Leave it like that. Okay, find x and y. This is an inscribed angle. So that makes this twice as big. So this is 180. That also makes this side of my circle also 180. Since my two chords are congruent, my two arcs are also congruent. So I take 180 and I divide it by 2 to get 90. So y equals 90. Because if two chords are congruent, then their arcs are congruent. That was from the 10-3. Just remind me of that. Okay, next one. So to find A, we need to add those two and set them equal to 180. So that will give me 12x equals 180. And that will give me x equals 15. Okay, I want to find the measure of angle A. So angle A equals 5x. So we're going to do 5 times the 15. Give me the measure of A. And that will give me 75 degrees. With angle C, same thing. It's going to be 7 times x now. And x is 15. So that will give me 105. You're gonna find B and D the same exact way.